When we're working with inequalities, the addition and subtraction properties are the same as working with equations. But with multiplication and division, things are a little bit different. And it's only when we're working or when we're dividing or multiplying by a negative number to find our final answer. But let's walk through a couple of the differences. Let's walk through some of the problems to show what the differences are. So here's my first inequality, and I have 4u is less than or equal to negative 20. And again, I'm solving for u. So just like with an equation, since I'm multiplying u by 4, I need to divide u by 4. I do need to divide 4u by 4, so I need to divide the other side by 4 as well. My 4's cancel, and I simply get u is less than or equal to, and I have a negative 20 divided by a negative 4, which leaves me with a negative 5. So my answer is u is less than negative 5. So far, it's very similar to what we did with equations, right? So let's take this problem. Here we have negative u is less than or equal to negative 20. So again, we're trying to isolate our u, and it's no different from the problem we just did. We're multiplying u now by negative 4, right? So what do we need to do? We need to divide negative 4u by negative 4. Remember, the sign in the numerator has to go along with it because that way we can cancel it. So we need to divide negative 20 by negative 4. If we're dividing by a negative number, if the number that's in the denominator here is negative, we have to switch our inequality sign. We have to swap it around. Up here it said less than or equal to. We have to make it a greater than or equal to. Our negative 4's cancel, and I still have my u, and now I have a negative 20 divided by a negative 4, and it gives me a positive 5. So my answer is u is greater than or equal to negative 5. And the reason it's different from multiplication and division for a negative number, let's think to ourselves here for a little bit. Let's say I started off with a true statement. We'll say 1 is less than 7, right? If I multiply both sides by a negative number, let's say I multiply negative 2. Whoops, let me not write that down. On both sides, let's go ahead and just multiply it by a negative 2 on the left, and we're going to multiply it by a negative 2 on the right. And we have, we're going to have negative 2 times 1 is negative 2. And over here, 7 times negative 2 is negative 14. Well, if we just carried the sign down like this is no longer a true statement, right? Negative 2 is not less than negative 14. If you think about it, negative 2 is here, and the more negative is a smaller number, right, on our number line. So this is wrong. And the way to account for that then is that we have to, we started off at negative 7. I'm sorry, 1 is less than 7. And we multiply both sides by a negative number. And remember, multiplying is the same as dividing. We have a negative 2, we have a negative 14 here. And because we multiplied by that negative number, we need to swap our signs. And that becomes a true statement. So that's why we can't simply keep the same inequality sign when we're either dividing or multiplying by a negative number when it comes to inequalities.